Hello class, this is going to be a trigonometry review. We're going to go over just a couple of things, uh, help us remember some of our trig functions that will help us within our statics class. So the first thing we want to do is if I have a right triangle denoted by our right symbol there, and we have sides A, B, and C, we also remember that the Pythagorean theorem, let's see, there we go. Pythagorean theorem is a squared plus b squared is equal to c squared. So we're just squaring both a and b, and that's equal to c squared. So if we're solving for c, we know that it's just the square root of that. So realistically, if you were given this point here and this point here, and you were given some kind of axis, you could use the distance formula, which was pretty much going to be your Pythagorean theorem. Okay, so one thing that we want to remember is when we're solving for an angle or we're solving for a side, depending on what's given to us, we can always remember SO, CA, and TOA. So let's look at this triangle here. Let's redraw this, and let's say we have a right triangle and theta, and we know that this is going to be 5 and this is going to be 7, well, whatever the units are, and we need to solve for theta. Well, we can look at SOHCAHTOA over here and say, alright, I have adjacent and I have my opposite. So I have my adjacent, have my opposite, but those won't work because you have to use the hypotenuse, but I have opposite and adjacent, so I can use tangent. So here I would come in and say, okay, tangent of theta is equal to opposite over adjacent. And then solving for theta, we know that we're going to take the arctangent of 5 over 7 to get our angle. If we were to, let's say, draw another one here, if we were to solve for the hypotenuse, we could use the Pythagorean theorem here, or we could even use one of these other trig functions. So we could say, now that I have my angle, I could use one of the sides to solve for the Pythagorean theorem. But let's say we're given this triangle here. Let's say I'm given this angle here, and this is 30 degrees, and I'm given that this side is 6. Well, I can come in here and say, alright, I can solve for my hypotenuse, and I could solve for my adjacent side. If I was solving for my hypotenuse, I would say I am given my opposite. So would I be using TOA or would I be using SO? Well, I'm using the hypotenuse, so I can come back and say, oh, I'm using SO. So I'm using my sine. Sine of 30 degrees is equal to the opposite over my hypotenuse. Now here you've got to move back the hypotenuse to the top, so you would multiply both sides by the height, and you get divide this side by sine of 30 degrees and divide this by the sine of 30 degrees. So what we have written here then, those will cancel, is 6 divided by the sine of 30 degrees. And if I punch that into my calculator, I would get 12. Of course it's 12. My hypotenuse is 12. So I hope this makes sense. There's some homework assignments that you can work on. You can look online if you need additional work on these. If we to look back at this triangle here, we could write out our formulas. We could say that the sine of theta would be equal to opposite over my hypotenuse, which would be c. Cosine of theta would equal the adjacent side over my hypotenuse, which would be c, or tangent theta would equal my opposite over my adjacent, which would be b over a. Or if you were looking for your alpha, we could say that the sine of alpha is equal to a over c, and that the cosine of alpha is equal to b over c, and that the tangent of alpha is equal to b over c. I'm sorry, let's see. A cosine would be adjacent over hypotenuse, so that would be b over c, and tangent theta would be opposite, so this is actually going to be a over b. Sorry about that. So you can use these formulas to solve pretty much for anything for a right triangle. Now, if we wanted to look at a triangle that's not a right triangle, we could use the we could use the law of cosines and the law of sines. So those two equations, so the law of cosines, if you were to be looking at the side C, so let's say that we were given A, side B, and this angle C, we could solve for side C using the law of cosines, and that equation would be C squared is equal to A squared plus B squared. Now those two are the sides, the lengths of those sides, minus 2 times A, that's the side, length, side of B, times the cosine of the angle C. So that's the angle, and the rest of these would be the lengths, and you'd be solving for the angle here as well. If you wanted to use the law of sines, you could use A over the sine of A is equal to B over the sine of B, which is equal to the C over the sine of C. So depending on what was given to you, in this case, let's say that and we're given, we'll say we're given this angle here was 30 degrees, and we were given that the side length was 5, and we were given this angle here was 40 degrees. We could solve for A. So we would say A, which would be what we're looking for, over, now that would be opposite, so it'd be sine 40 is equal to B. We could use this as B, or we could use this as C. It doesn't really matter what we're looking at. So if we said this was C, then we would cancel out B over sine minus sine of B. Then you could say C is equal to 5 over the sine of 30 degrees. So here you would say cross multiply, so you would land up with A times the sine of 30 degrees is equal to 5 times the sine of 40 degrees. So you would actually divide by the sine of 30, divide by the sine of 30. So A would equal, let's punch that in real quick, I get 5, enter 40 sine times, and then divide that by the sine of 30, which I get 6.4. 6.4, so this side would be 6.4. Now I could look at that and say, alright, this angle is 40 degrees, this angle is 30 degrees. This was length of 5, this was the length of 6.4. So common sense tells you that this side should be longer than this side. Real quick, what would be this angle if we called this theta? How would we solve for that? Well, we know that all triangles are 180 degrees, so we could subtract 40 and 30, so that's 70. So theta then would equal 110 degrees. So just a real quick trig thing. Okay, I will put up a couple of examples. If If you have any questions, please let me know. Thanks for listening.